So this is our first class. This is our first class. Though the syllabus, that is first welcome all of you. After this second sem, this is my first class, I think so. So today we are going to start our classes. So sharply you should always join the class. Okay, so that I can admit only once at a time, so that I can proceed that. Now we will see the first bit of your syllabus, that is ordinary differential equations. Dear friends, today we are going to see the chapter called as a ordinary differential equations. What is this ordinary differential equation actually? So ordinary differential equation andre ಏನು ಇಲ್ಲಿ first. Okay, so we'll start with that is called as a ODE, ordinary differential equation. Write down heading as a ordinary differential equations. Ordinary differential equation. So what do you mean by a ordinary differential equation? Before we will go ahead, first I will define a differential equation. What do you mean by a differential equation? That is this one. Differential equation. What do you mean by this differential equation? So right, it's right. So it's nothing but an dy by dx we can say, right? So here dy by dx means what does it is going to indicate? So I will tell you each and everything. Its most applicable areas are there. If you see the physics, when we make an experiment, when we do the experiments, after that we will draw a graph. In that we have to find the slope. There we have to take the dy and dx, right? There we will take dy by dx there also. So in this way we will go ahead. First I will define first a differential equation. So let us consider a function. We know that how we are going to denote a function. Y is equals to f of x, right? Y is equals to f of x is a function. We can denote like this. Now if you differentiate this, what we are going to get? Derivative dy by dx is equals to f dash of x, I can say. Similarly, if you go for another one, d square y by dx square is equals to f double dash of x. Like this I can go ahead. Up to nth term I can make the differentiations. Okay. So this is differentiation, that is derivatives we are going to see here, right? So now I will write a function. Now this is first function. Okay, I have wrote it. Now I will write another function. You can see it here. That is y, some function, that is this one, f of. Here in this function, in the first function, what are there? X is there, y is there. That is dependent variable as well as independent variables are there. So if you write that x, y, with that, if this one is there, that is derivatives are there, then this type of functions are called as a differential equations, right? This type of functions, that is a function which has x, y and its derivatives. That means a function which involves dependent variable, independent variable and the differential coefficients of a dependent variable with respect to the independent variable are involved is called a differential equation. Now we can say, now I'll write it in general. How we can write that? This is just an introduction to the differential equations. So if you want, I can say, let us define a function. We know that f of x comma y I can define. Here only two variables are there. Okay, I will write this with a derivatives. This is a function with a derivative, I can say. Then what will become? This is my differential equation. So now I can define that. An equation in which the independent, dependent variables are there and the differential coefficients of dependent variable with respect to the independent variables are involved is called a differential equations. So that is, I will write an equation so that we can understand in a better way, right? So what is the example for this one? I can say like this: dy by dx plus x is equals to 3. Now you can see it here. This is the example. We can take it. Like this, there are so many examples will be there. But in general, I can say that a general equation format I can write it. An equation that is involving a function is there, x is there, y is there, dy by dx is there, d square y by dx square is there. Then this type of functions are called differential equation. We know that dy by dx means dy by dx means we know that this is independent variable, this is dependent variable, right? So this is a function where it involves this one, that is independent variable and dependent variable and a derivative with respect to independent variable. Then that type of equations are called a differential equations, right? So there are two types of differential equations that we are going to see. One is ODE, ordinary differential equation, and another one is partial differential equation, right? So one is ordinary differential equation and another one is PDE, that is partial differential equation. So one is called as a PDE and another one is called as a ODE. An ordinary differential equation and partial differential equation. Two types are there. So now in this sections we are going to see this one, that is ODE, ordinary differential equations. Ordinary differential equation. This is the topic that we are going to deal. Now, so what do you mean by ordinary differential equation? We know that differential equation. What do you mean by differential equation? A function will be there in which an independent variable, dependent variable and a differential coefficients of dependent variable with respect to the independent variable are involved. It is called as a differential equation, right? This is the thing. That means in another way we can say that it is a relation of independent variable, dependent variable and derivatives, I can say. You can see it here. It is a relation between x, y and dy by dx, so on. You can see this. It is a relation between which one? An independent variable, dependent variable, and its derivatives. Right? So now we will see what do you mean by ordinary differential equation. An ordinary differential equation is an equation which have only one independent variable and one or more dependent variables and derivatives with respect to the independent variable. I will explain you. So what is this? An differential equation has only one independent variable. So we know that what is this? Dy by dx. This is differentiation. We know that. So with respect to x we are making, we have learned all those things. This is independent and this is dependent. Okay. And differential equation, this is a differential, think that this is a differential plus something are there, and differential equation which have only one independent variable. That means x is an independent, it should be only one, it should not be two things should be there. How means? Sir, I have dy by dt, sir, then I will go ahead by y with respect to x, sir. Here you can see there are two independent variables. It should not be there. Only one independent variable should be there. Right? And only one independent variable should be there. First thing. And one or more dependent variable. One or more dependent variable. It may have y. It may have dy by dx is there. Plus dt by dx is there. It is, what is this? This is a dependent. It may have two or three dependent variables. But and at the same time, it should be differentiable and derivative with respect to the independent variable only. Independent variable x anta tondi anta itkodu. If you consider x as an independent variable, only x should be there and its a with respect to x should be differentiated. Then we can say that the type of functions are called as ordinary differential equations. Right? At the same time, we will give the notes. Don't worry about all the things. I will send you the PDF notes. Okay? Now, so this is about the differential equation. I can give you an example for this one where we can see that an independent variable will be there, its the derivative will be there, and a dependent variable will be there. I can say dy by dx plus x square times of y is equals to tan x. If you see this one, independent variables are dependent and independent variables are there, but the derivative with respect to which one? You can find here x, that is the independent variable. The derivatives you can find with respect to the derivative, the independent variable. Right? So this type of equations are called the ordinary differential equations. Right. Now, order. We will define the order and degree of the differential equations. What do you mean by order and what do you mean by degree of the differential equation? So what do you mean by order? What do you mean by degree? I will write for that. I will write some examples so that we can understand in better way. Right, friends? So now I will write a differential equations. So d cube y by dx cube plus 3 times of d square y by dx square plus 4 times of dy by dx minus y is equals to cos 3. Now, this is an equation, right? This is a differential equation, I can say. Now here in this, what is the order and what is the degree I will define. So what is the order means? The order is nothing but an highest derivative appearing in it, I can say. Highest derivative appearing in it. What is the derivative here? It's the third order derivative. This is second order derivative. This is first order derivative. See, the derivatives that are involved in it is nothing but an its order, we can say. That is, what is the order? Then I can say it's order, highest order. Order is 3. Why? Which is the highest order? That how many times it has been differentiated? 3 times, I can say, indirectly. So that itself, highest is nothing but an its order. Right? What is its degree? Its degree means here. This is the degree. The degree is 1, remember this. Here degree is 1. Order means what? The derivative. How much highest power derivative I can. Highest derivative in the differential equation. Right? So that is called the derivative. And if you find the degree, is the power of the highest order derivative. What is the power? Its power 1. Therefore it is 1. Degree is 1. Degree is 1. If you find that its degree is some 4, I can say, then what will be our order? Sorry, what will be our degree? Degree will be 4. So it is going to change like this. The highest derivative is nothing but an its order, and its power is nothing but an degree. Remember this. Right, friends? So this is about the order and degree, we can say. Similarly, I can give you one more example where we can define that degree and order. Just I'll rub this. So I can write that example, one or 2 examples where we can see that how that will be there. 3 times of y minus 4 times of x into dy by dx plus 7 y square plus 6x is equals to 0. Right? Here what is the order if we see here? The derivative. 1. Order is 1. Right? Order is 1. What is the degree here? Degree is also 1. We have to see the power of the derivative. Right? Okay. Similarly, we will go for another one example. D square y by dx square plus 1 times of, and I will write its square root, is equals to some d square y by dx square, I will say. So now, what is the power of, what is the order of this differential equation? Order is 2, okay. And what is the? No. Always remember that the degree or the order will be always a whole number. It cannot be a fraction, first of all. It cannot be a fraction. So what we have to do it? We have to make the squaring both sides. Squaring both sides. If you do, what happens? D square y by dx square plus 1 is equals to d square y by dx square whole square. Now tell me what is the order? order is 2. There is no change in the order. But what is the degree here? You can see 2 is the degree. You have to always convert that. You cannot write the fractions. Your order and degree cannot be in fraction. Remember that. If it is given in the fraction, you have to convert that. Then only we can define our order and degree here. Okay? Right. One more thing, I will give you the example. Let us check another one example. Because when you go for the CET or some competitive examinations also, this order and degree questions will be there. Remember this. So I will write d square I by dx square whole square plus dy by dx whole cube plus x is equals to 0. Right? I will write this one. This is y. Okay. Now, this is dy by dx square. Remember that. Okay. Now, tell me, what is the order of this equation? Order is 2. Degree, what is the degree? Remember. So, that's why I told you, you should remember the definitions. All of you mute yourself quickly. See here. What I told you is, you should see the highest order and its degree. What is the order, highest order in this? I know that this is the order. This is the order of the, this is the order, we know that. Right? So its power, what is its power? Its power is 2. Therefore, order is 2 and degree is also 2. Now, ಯಾವ್ದ್ರ ನೋಡ್ಬೇಕು? ಯಾವ್ದ್ರದ್ದು ಆರ್ಡರ್ ನೋಡಿರ್ತೀವಿ ಅದರ ಪವರ್ ನೋಡ್ಬೇಕು ನಾವು ಯಾವಾಗಲೂ. We should check the order's power. What is the power? That will become the degree of the differential equation. Right? So this is the small things where we have to concentrate. Now next part. So just we have seen the differential equations, and then we have seen the order of it, degree of it. Now I will show you how a ordinary differential equation will be formed. How it can be formed. Okay. So after 15 minutes, I think our session will end. We have to rejoin again, all of you. After 10 minutes, you have to rejoin, all of you, again. So at the same time, you can get this video link will be there in some YouTube or in my YouTube, as well as the same video will be uploaded in your WhatsApp groups also, so that you can repeatedly you can watch this videos. Okay. Now, so formation of ordinary differential equation. So how it will be formed? I will take an example so that how a differential equation will be formed. We can see this. So let us consider an equation. So its equation is like this. Y is equals to a into cos x plus b sin x. Okay. So this is the differential equation. Sorry, this is the equation I have got. So now I will make the differentiation of this. So dy by dx, what will be my dy by dx? Dy by dx is equals to, I can say this is minus of a sin x plus b cos x. I can get this after differentiation. Right? So if you want to solve this, means, what do you mean by that? We have to remove the arbitrary constants. That is, we have to remove these two things. That is a and b. Here we have to remove these two things. This and this. So still I cannot do anything here. So what I will do it? I will differentiate again this one. If you differentiate again this one, what we are going to get? We are going to get d square y by dx square is equals to what I can say, this is minus will be there, a into sine will become cos x minus of b times of sine x. Right, I am going to get this part. So now what I can do, I can take a common here minus, so I can write a into cos x plus b sin x. If you see this and this, shall I substitute over here? This will become minus of y. So here d square y by dx square. Now you can see it here. Now this is nothing but my differential equation, that is d square y by dx square plus y is equals to 0. This is our differential equation. So this is called a differential equation. How we have got, you can see it here. That means we have to remove the arbitrary constant. We have to remove the arbitrary constant, that is a and b. How many a and b's are there? Sir, there are two arbitrary constants are there. I can say a and another one is b. So what is the degree? If you watch it here, its degree is also here. Degree is also, sorry, its derivative is also 2. Its derivative is also 2. You can see it here. What is the derivative we have got? 2. There are 2 arbitrary constant, therefore its degree, its order is 2. So I can say that indirectly we can say that to solve, if you have a order is 2, I will get the 2 arbitrary constant for a function. Otherwise I can say that whenever there are 2 arbitrary constants are there, I can get the order of the differential equation will be 2. Okay, this is in note actually. So we can, how much arbitrary constant we are removing? 2 arbitrary constant. Therefore differential equation will be of order 2, I can say. Right? So in this way, and differential equations can be formed. Right, friends? So we have formed this. In another way, we can say this is nothing but the solution of that. That is, and differential equation can be formed by giving a relationship between the variable x and y. So now we talk about this solution of a differential equation. What do you mean by a solution? What do you mean by a solution? So here we know that here solution means what? An equation will be there. We will solve that, and what we will do after solving that, what we can get? A solution will be there. So just we have solved this. We have solved this. You can see it here. This we have solved it here. This we have got differential equation. This is nothing but the solution of this one. How much? Just if you substitute the y value there, we will satisfy. It should satisfy that. Then we will call, that is called as a solution for a given equation. That is, I will write how an solution will be there. So we know that ax square plus bx plus c is equals to 0. Some equation is there. If you solve this, what we are going to get? We will get the value of x. Some 2 values will be there. Right? 2 values will be there. X values. 2 x values will be there. So what do you mean by these are the solutions? This one and this one are the solutions for this equation. For equation number 1. When we can say that it is a solution, if you substitute these values in this, it should satisfy. It should satisfy. Satisfy means RHS should be equal to LHS. Then I can say that this is my solution. Otherwise, it is not my solution. Okay. So now we have got, if you solve a equation, differential equation, you will get some equation. That equation, if you substitute, it should satisfy. Then we will call that an equation is called a solution for the differential equation. So we can define like this: a solution of a differential equation containing as many constant as the order of the equation is called as a general solution. There will be two types of solution. One is a general solution and another one is particular solution. When we can say that a general solution will be there for a differential equation, I will get it. So as I how a differential equation will be formed, we seen that. So if I will take this equation dy by dx square plus y is equals to 0. So if you solve this, I will get the solution as y is equals to a into cos x plus b into sin x is my solution for this differential equation. So for this equation number 1, solution is this one. Equation number 2 is the solution. Right? Now, here, what do you mean by general solution and particular solution? General solution is this one. Then particular solution means what? This is my general solution. Okay. What do you mean by a particular solution? If you substitute the value, particular values for this arbitrary constants, if you substitute the values for this arbitrary constant, that is, if you substitute the values of a and b in this solution, then it will become a particular solution. Then it will become a particular solution. So a solution which is obtained from the general solution by substituting a particular value to the constant involved in it is called a particular solution. Remember this. Now I think you have understood what do you mean by a particular solution, right? So now another one, GS and PS we'll call it. When we'll solve the problem, we'll say PS as well as GS. There is another solution is called as a singular solution is there. Okay, I will tell you how the singular solution will be there. A solution, I will get a solution. Think that for some equation I have got y is equals to cos x plus sin x. Think that this is solution for some equation. In this equation, you can see there is no arbitrary constants. There are no constants. Then this solution is called as a singular solution. This solution is called as a singular solution. Now, we have seen the differential equation and how it will be formed, what do you mean by a solution, and how many types of solutions will be there for a differential equation. Okay, all this we have seen. Now, this is an introduction about the differential equation. So most important concept we will talk now.